Hello everyone. I hope all of you are well by the grace of Almighty under this corona circumstance. Today we are going to give our presentation. This presentation is submitted to our honorable teacher Miss Shostika Roy. So here is my team members. First myself Adur Chaudhary, and then let introduce to my beloved teammates Mr. Tushar Acharya, Mohammad Ibrahim Hussain, Unik Nandi, and then Kapil Das. Now came to the topic in which today we are going to give our presentation is phase locked loop technique of FM demodulation. Before going to explanation, I want to attach here a little history of PLL. The concept of phase locked loop or PLL was first emerged in the early 1930s, but the technology was not developed as it now. The cost factor for developing this technology was very high. Since the advancement in the field of integrated circuits, PLL has become one of the main building blocks in the electronics technology. In present, the PLL is available as a single IC, which name is SA or NE 560, and there are many other series, which is generally used to reduce the buying cost, and the discrete ICs are used to construct a PLL. So let's introduce to PLL. So first of all, what is phase locked loop or PLL? A PLL is a feedback system that includes a BCO, a phase detector, and a low pass filter within its loop. Its purpose is to force the BCO to replicate and track the frequency and phase at the input when in lock. The BCO output can be used as a local oscillator or to generate a clock signal for a digital system. Now I am going to tell you about the types of phase locked loop or PLL. Generally it is 4 types. First one is analog phase locked loop, which is shortly known as PLL. The second one is linear phase locked loop, which is shortly known as LPLL. The third one is digital phase locked loop, shortly known as DPLL. The another one is all digital phase locked loop, shortly known as ADPLL. And the last one is software phase locked loop, shortly known as SPLL. All the types are not commonly used. Among this type, digital phase locked loop is very popular because it has many advantages such as high reliability, stability, and easy adjustment, and so on. In this slide, there are some examples of phase locked loop. There are several different examples. The simplest is an electronic circuit consisting of a variable frequency oscillator and a phase detector in a feedback loop. By this slide, we came to know about the working principle of phase locked loop. In this slide, we can see two pictures. One is oscillator and the another one is phase detector. The oscillator generates a periodic signal and the phase detector compares the phase of that signal with the phase of the input periodic signal, adjusting the oscillator to keep the phase matched. How can we demodulate a signal? A simple and effective FM demodulation technique involves a high-pass filter for FM to AM conversion, followed by an AM demodulator. A high-pass filter-based FM demodulator is preceded by a limiter to prevent amplitude variations from contributing error to the demodulated signal. Now came to the applications of phase locked loop. A FM demodulation networks used for FM operation. A PLL is used in motor speeds controls and tracking filters. It is used in frequency shifting decodes for demodulation carrier frequency.
Thank you so much, my friend Mr. Adur Chaudhary, for your good presentation. Hello everyone, I am Unik Nandi. Now I am going to discuss about the next topic. Now the topic is FM demodulation. FM demodulation is a key process in the reception of a frequency modulated signal. Once that signal has been received, filtered, and amplified, it is necessary to recover the signal modulation from the carrier in this process that is called demodulation or detection. And the next slide about FM modulation basics. We know that in any radio that is designed to receive frequency modulated signals. There is some form of FM modulator or detector. In this slide we can see there has a circuit diagram. Usually this circuit diagram defined as this circuit takes in frequency modulator RF signals and takes the modulation from the signal to output only the modulation that have been applied at the transmitter.
Hello, I am Muhammad Ibrahim Hussain. My topic is demodulation principle. In this diagram, we can see that this block diagram consists of the multiplier, the low pass filter and the voltage controlled oscillator VCO. VCO produces an output signal VT, whose frequency is proportional to the input signal voltage DT. Initially, when the signal DT is 0, the multiplier produces an output having a high frequency component and a low frequency component. Hence, we get the modulating signal MT from this output of the low pass filter. Now, I would like to invite my friend Kapil Das.
Requirements for the FM demodulator. One of the chief requirements for the FM demodulator is that it should have a response that is as linear as possible over the required bandwidth. A further requirement for the FM demodulator is that it should not be sensitive to amplitude variation, as the modulation is carried by only the frequency division. No amplitude sensitivity is wanted. The resilience to noise is a major factor in providing low noise FM reception for applications like high fidelity audio broadcast. Slope detection. This is a very simple form of FM demodulation. It relies on the selectivity of the receiver itself to provide the demodulation.
Phase locked-up technique for FM demodulation. It is possible to use a phase locked-up loop to demodulate FM, the PLL, and can therefore be added with very little increment cost to an overall receiver clip, and hence the radio receiver also. Next, PLL FM demodulator block diagram. The basic concept of the operation of the PLL is relatively simple, although the mathematical analysis and many elements of its operation are quite complicated. Let's see. The diagram for a basic phase looked up shows the three main elements of the PLL phase detector. The output from the phase detector is passed to the loop filter, and then filter signal is applied to the voltage control oscillator. The voltage control oscillator VCO within the PLL produces signal which enters the phase detector. Now we are going to demodulate an FM signal using IC XR2212. A simple PLL FM demodulator circuit using IC XR2212 is shown here. XR2212 is a highly stable monolithic PLL IC, specifically designed for communication and control system applications. The IC has 0.1 Hz to 300 kHz frequency range. When there is no carrier modulation and the input FM signal is in the center of the passband, the VCO tune line voltage will be at the center position. When deviation in carrier frequency occurs, and this variation is proportional to the modulation done to the FM carrier wave. This voltage variation is filtered and amplified in order to get the demodulated signal. Now let's see the circuit diagram. Composite FM signal is applied to pin 2 of the IC. Input impedance of this pin is around 20 volt and the voltage swing of the input signal must be between 10 mV to 5 volt. Capacitor C5 is meant for frequency compensating the internal output op-amp. The capacitor C5 is connected between pin 6 and 8 of the IC, and its range can be 20 pf to 10 uf. C4 is the input supply by pass capacitor. Free riding frequency of the VCO is determined by the external timing resistor RO. Value of the RO can be between 10 to 100k. Rx can be used for fine tuning the VCO frequency. R1 and C1 forms a PLL loop filter. Resistor RF and RC sets the gain of the output amplifier section. That's all. Thanks for listening us. Any questions?